Hello wonderful person and welcome back. So now that we're done with the inner planets and even the outer planets, we come to the fringes of the solar system, the edges. And where else to begin at the edges than the famous Pluto? This is the backside of Pluto actually. You can notice how the atmosphere glowed in the brightness of the sun. Pluto is a fascinating little object. It was earlier a planet, but a decision was made in 2006 by the Astronomical Union, where it was decided that Pluto, along with several other objects, would be classified as dwarf planets and not as planets. However, I still think it's a planet because look at it. Cute little Pluto. Pluto is made up of 40% ice and 60% rock. Out of the ice, mostly the composition is nitrogen, carbon dioxide, methane. Even the atmosphere that I just showed is mostly just nitrogen. An interesting thing about this atmosphere though is that it is periodic. You see, the atmosphere is really tenuous. It is thin and almost not there. What happens is that the nitrogen ice present on the surface of Pluto starts to sublimate, essentially melt and become gas when it approaches the sun. So, on its orbit's closer points to the sun, it has an atmosphere, and on its farthest points, nearly nothing. That's a really beautiful thing. In fact, the change is so abrupt and so drastic that the surface of Pluto might also change over just one orbit. Pluto was explored by the New Horizons probe in mid-2015. That's the imaging you see right here. All of these details were captured by the New Horizons probe. And that's also the reason why only one side of this planet is so beautiful looking, in the simulation at least, because the other side wasn't explored well. Pluto has all sorts of features on its surface. Plains right here, mountains in this region, and craters in this region. But more than all of these, Pluto is really famous for something else. Something that is visible right there. That thing. Charon. Now, Charon is a moon. And it's a very generic moon if you look at it. Rocky, moon-like, icy. Nothing much, right? Well, essentially yes. However, both of these objects together, Pluto and Charon, make for a very interesting system. You see, Pluto and Charon have the largest ratio by mass of any parent and moon in our solar system. At second place is Earth with Luna. What this means is that Charon does not actually orbit Pluto. Both of these orbit something else. They orbit their center of mass. Essentially, the center of mass is a point where you could balance both of these if you were to put them on a rod. This point right here, this is the center of the mass. In astronomy, the center of mass is known as a barycenter. And this is right here. This is it. What this means is that both of these objects orbit the barycenter and not each other. Charon orbits this point and Pluto also orbits this point in this small tight circle. In fact, this is visible if I were to. So to see that, I'll zoom out a little and then I turn off the orbits. So now if I were to speed up time, you'd see that both of these objects revolve around this point. Look. In fact, what's also happening over here is that both of these objects are tidally locked. What that means is that only one side of each other is shown. Let's see this better. Let's go over to Pluto and try to look at Charon. So here we can see Charon. In fact, let's actually go to Charon only, because Pluto is more beautiful. Let's land on its surface right about here. And from here, we look up to Pluto, right there. Now I'm going to start to increase time, and you'll see that no matter what happens, only one side of Pluto is ever seen. We can do anything we want, but we'll only ever see one side. To me, this is quite poetic because it looks like a couple to me, a couple who are deeply in love but are trying to see each other's other side, but they are never able to do it because they're locked in this kind of dance, a waltz if maybe. It's an interesting little phenomena coming about due to the play of gravity. An interesting system indeed, Pluto and Charon. After Pluto, there are a few other objects left in the solar system, quite interesting ones. For example, this one right here. This is Haumea. It's a dwarf planet just like Pluto. It looks kind of like a egg. Haumea is an icy rock floating around far, far away from the sun. It has two small moons right here, both of whom orbit pretty close to it. The outer solar system is home to a bunch of such rocks. Because the gravity is quite weak here, these small objects can have large hemispheres and can have many moons and rings without having to be large. However, there is a very interesting theory regarding something much, much larger lurking in this part of the solar system. There's a prevailing theory that there may yet be another undiscovered planet out here, a planet roughly 10 times the mass of the Earth. This would be a mind-blowing planet. Not because of its presence, but because it wasn't discovered yet. With our technology, we've scanned almost every part of our solar system, but we haven't yet found it. So if it's still hidden out there, that means that it must be quite remarkable. The outer solar system has tons of these rocks, as I just said. You can see a few of them with these. Now, you'll notice something very different about them. Their orbits. While most planets have their orbits in this nice little line, a plane if we may, these objects have their orbits thrown around randomly. That's part of the reason why none of them are called planets, because they just don't have mass enough to maintain their own orbit. They were thrown around by Neptune, and this is where they've ended up. But this is not all, really. These objects are just a limited number of dwarf planets and asteroids that are seen over here. The solar system is home to much, much more than that. And to show you that, I'll quickly go over and turn a few objects on, and then you'll see this and this. Wow, that's a mess. These are the orbits of all the other objects out here. Look at how far they extend. The blue lines represent comets, and if you go close enough, the white ones, they represent asteroids. This looks like a mess, doesn't it? There are hundreds of thousands of these rocks out there. Comets are put into elliptical orbits. They get really far from the sun, slow down, and then come back to the sun again, hurtling towards it, and then burning up their ice showing us a beautiful tail. Halley's Comet is one of them. And just like Halley's Comet, most of them have long periods before they come back. Some of them are even thrown out. For example, these. The longer lines are actually comets that have been thrown out of the system. They will never return. They can't return. But for our sake, let's turn these off again. The solar system is much, much more than we can ever imagine because of how intricately everything is placed.